Okay. Right, so I should probably talk about what I'm going to talk about, which is SaltStack and deploying Dockerized apps with Salt. It's something we've been doing a lot of recently. We use it for a project called Do It, which I'll talk a little bit about. And it's worked out really well for us. And hopefully our learnings, you'll be able to do something cool with it as well. So I'm Chris. Hi. You can find me at Kraken on Twitter, GitHub, anywhere. Previously, I've worked at a company called Poke, an adaptive lab, before working here. At Poke, I was exposed to the whole DevOps world. I was a lowly junior. I never touched servers really before. And at Poke, we had to do it because there were no sysadmins. So I learned about DevOps there. And at Adaptive Lab, we were deploying like a huge, big social app, which munged loads of social data, and it was deployed across lots of servers. So there was a big learning experience about how to deploy to large scale services, like unlike at Poke, where we were deploying advertising projects that lived on a couple of servers. This large scale project lived on loads, and it would fall over in many different ways. So soon, we're a product development agency. We do everything from UX, branding, design, all the way to build. So we'll do everything or just little bits and pieces of that. We've been very lucky and fortunate to work with companies like Resident Advisor, Peabody, and we're currently obviously working with Do It and Team London there as well. So we've only been around like about a year, so we're very fortunate to already have worked with these kinds of clients. So Do It is a volunteering platform. It's the UK's biggest volunteering platform. It's been around since 2004, I think, 2004. The current build is a Java-based project. It's quite difficult to work with. It hasn't been updated since it launched, since 2004. So it takes about, it has around about 3.5 million page views a month, which is actually quite a lot, and 250 uniques a month as well. And 100 concurrent users are on the site volunteering away. And one of the most interesting things about it is that volunteer centres, who are physical places and shops, deploy opportunities for people around. So we have lots of different things that we have to contend with and deal with. So this is the old Do It. As you can see, it looks very much like a 2004 website. That would probably work very well on an iPad, but not very well on anything else. So we're basically rebuilding it, and this is what we're launching on the 10th of December. It's already being used behind a password by the volunteer centres and organisations like the Red Cross, Marie Curie and stuff to populate it and get stuff in. And you'll be able to go there, and if you ever want to do volunteering, it's the best place to find volunteering in the UK because it's basically the only place to find volunteering opportunities in the UK. So our approach was to use new modern technologies. We know Python very well here. All the developers here have come from Python backgrounds, so that was a natural choice for us. AngularJS is a modern JavaScript library. I'd personally worked with Salt a lot at Poke and Adaptive Lab, so Salt again was a natural choice for us. Flask, the one in the middle, is a micro framework for Python. So it's like, it basically doesn't have any batteries included. It's basically allows you to root and render views. That's basically all it does. We didn't start using Docker initially. We looked at it and we wanted to use it, but to get the app going, we didn't use it. But then when the front-end development started, we needed a way to get our back-end environment to our front-end developers. And the easiest way to do that was to Dockerize it, so that our front-end developers can just take down a snapshot of what develop is at any one time and just run it. So that made sense for us at the time, and it just kind of like spun on from there. So it was like, okay, so if our front-end developers can have it, then why can't our servers have it at the same time? So it ended up Dockerizing everything, basically. So I thought that I would give Docker 101. How many people know Docker, roughly?
Do I count? Maybe half.
Maybe. So maybe I'll speed through this a little bit quicker, because I think pizzas will be here in 5. Oh, they're already here. Yeah. So I'll speed through this. Okay, so Docker, a way of, it's a wrapper for Linux containers. So Linux containers have been around since 2006, which is a method of running Linux systems within Linux. It's like a thin virtual machine. There's not a lot of overhead to it. So Docker gives us a way of interfacing with that. And Docker, I suppose, has kind of exposed Linux containers to an audience that would probably necessarily would never have heard of it or wanted to use it. The idea of Docker is that you ship your application with the operating system and you run one process inside that Docker container. And then you scale your Docker containers according to how many processes you need to run. It's easy to build. Anywhere that supports Docker, you can run a Docker container. And this is an example of basically running bash inside a Docker container. It's that easy. You just do docker run, the --rm and it bit I'll get to in a bit, and there it is. You're in a Linux container there with bash. That's it. It's really easy. Version control it kind of gives version control for Linux containers. So, for example, if you add stuff to your containers and you want to commit that stuff for later, you can just commit those changes you made in that container onto your base image, and then you've got those changes for later. So it's an example of running apt-get update, saving that commit, and then running apt-get install curl, saving that for later, and then I can just run curl later, and it's just there. I don't have to do any more. So you could use it that way, but that's quite clunky. So the best way to use it is with a Docker file. And a Docker file is a set of instructions of what you want your image to look like. So a Docker file will, here, we're doing the exact same process as we did on the previous slide of installing curl, but we do it in just a couple of lines. And we use the Docker build with the -t flag to give it a name, and that will build that image for us in just one line. And then use curl. The great thing about that is that you get an image and then you can push it up somewhere. So you can host it somewhere and you can access it later. So here we're just pushing it up to Docker Hub. And of course you can then pull it. So there are loads of images on Docker Hub. People have written Redis containers, Postgres containers, Rabbit containers, all kinds of stuff. So there's literally hundreds of thousands of Docker containers there to use. They've also got official partners like Ubuntu and other distributions. So it's all really good. So if you want to configure your application, the best way to do that is to pass environment variables to it. So the -e flag sends a foo variable with the value of foo into your Docker container. So you echo foo, and there is foo. Pretty simple. If you want to run, by default, Docker containers will run in an attached mode. So everything you see in it will output in front of you. The detached mode means it runs in the background. So it's a bit like running a daemon process, for example, or something like that. So a good thing, so by default, Docker containers will get random names and they'll get hashes as IDs and stuff. They're not very human-friendly to work with. So giving them a name means that you can then stop and start them and restart them really easily. So you can start, restart, etc. Logs I'll come on to later because there's some gotchas with those, but you can see what it's doing just by doing logs --follow, and you'll see what your container is doing or it's running in the background. Attaching to a container, so if you want to see what's going on real time, then you can attach to it, or you can start your background container in attached mode, and then you can see what it's doing. One of the new ones that's come out in the recent Docker versions is exec, and this for me was like a real winner because a lot of the time you want to see what your container is doing and you want to get into it and you want to hack around with it. If you're debugging, you want to know what's going on. So exec allows you to get in there and see what it's doing. You can also remove containers if you don't need them anymore.
Have a beer, guys.
And images, you can obviously remove images as well. Some more advanced stuff, so you can link containers together. So for example, if you have a container that's running and it needs to talk to a RabbitMQ server, you can use the link flag to link it to another running container. So here I've got a Docker container running, it's called RabbitMQ, and then I'm running another container and I'm linking RabbitMQ. I'm going to call it RabbitMQ in the running container, and then I have access to RabbitMQ inside that container. Volumes, so sometimes you want persistent data. So if you were to stop and remove your container, that data that's stored in that container is gone forever. You can't get it back, it's gone. So if you need to have persistence, so like if you're uploading images or database, for example, you want to have some persistence so that your data can hang around, but your containers don't necessarily need to hang around. So here, the top command is linking a path on my host to a path in the container. The second one, you can do actual files, so you don't need to do a whole directory, you can just do a single file. So here I'm linking data PostgreSQL on my local host to where Postgres would put its data inside the container. And then I can then stop this container, remove it, start a new one later, linking the same directories, and then my data is still there. So this was a new one. This is fairly new. You can run Docker in Docker, which is really powerful. And when I get to do the live demos with Salt, you'll see that I'm using Salt inside a Docker container that runs Docker. So you can do Docker and Docker and Docker and Docker. You can go for infinity if you want, and that's what this privilege flag does. Don't use that in production. We don't. I don't know why you would, but it's really handy for development if you want to test stuff. So we're getting to Salt soon. This is a really simple application that I'm going to take you through. This is a Flask application. All it does is it prints out hello world. It's really simple. There's nothing more complicated than that. And then we've got the other thing I'll show you in a second is the Docker file, which is this. So this is a more complicated Docker file, and this is how we do it, more or less. So the first thing we do is we run apt-get install and install our dependencies and clean it all up. It's important that you do this stuff in as little commands as possible, because Docker will build up a layer, and the more layers you have, the more space it's going to take up on disk, and the longer it takes to push up to Docker Hub and to pull down. So if you do it all in one command, then it's going to flatten it down a bit. We add our local foo directory up into the container. We set a working directory. We then install our application. We expose the port 5000 because that's what the application is going to run on. And we give it a command. This is like our entry point into the app. So if we do docker run foo, it will just run this by default. But we can override that. So the process is you run docker build, tag it. The soon foo bit is what it will be in Docker Hub. So we've got a repository up there. So if you go to Docker Hub soon/foo, it will be there. And you can download it and you can play with it. So you push it, and then you can run it locally. The -p flag here says that I'm exposing port 5000 locally on my host to forward it to port 5000 in the container. So if I went to localhost 5000, that would forward on to 5000 inside the container. So now I'm going to talk about the actual cool bit, the Salt bit, which everyone's here for. Using Salt and Docker together, a few things you need. Obviously you need Docker, and obviously you also need a way to interface with Docker's REST API. So Docker has a HTTP REST API, and that's what DockerPy will do for you. So that will interface with Docker, and that's how it all works. So you need to make sure you have the latest version of Docker. So you just do your normal package repo, things from that PPA. Install Docker, make sure the service is running. If Docker's not running, it's not going to work. And make sure you've got DockerPy. And remember to include reload modules true after you've installed it. Otherwise, again, Salt will think that DockerPy doesn't exist, and it won't work. So this is like the most basic, easiest way you can do it in Salt. So here, what we're doing is we're pulling the repository we created earlier. So we created soon foo. So what we're saying here is we're saying pull the latest version of soon foo. Force true will basically say always check for the latest version. So if you don't put that and the image already exists, Salt won't pull the latest version. And obviously you require that DockerPy is there and service is running. This is where things differ a bit from how you use Docker on the command line to how you use it inside Salt. So where you would normally just do Docker run, blah, 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 here you have to say docker.installed. And basically what that means is that will create the container for you, but not run it. So it creates your container environment. So we just say we give it a name. So we want to call the container foo. We want to use the soon foo image. We require that the image exists. And then we can run it. And here's where you declare your port bindings. Right. So here's where you declare your port binding. So this is where we can say that we want to bind 5,000 in the container to, if you leave the host IP blank, then it just means localhost, and to 5,000. And we require that the container exists. And that's it. And that is all you need to have your image pulled and a container running and your app running. That's it. It's really basic. But really in production, it's not really enough. There are things that you need to do for that. So for example, if you deploy a new version of your image, you need to stop the running containers, you need to remove the running containers, you need to recreate your containers and start again. So you can watch for changes to that image. So when a new image comes down, because we've checked for force true, so we always check for a new image, we can then apply command.wait, and we can run docker rm-f and the name of the container. We can't use docker.absent because if you just run that, it won't watch for changes, it will just run normally. And then every time you run your salt states, it will always remove that container and then recreate them again. So you only really want to remove your container and recreate them if there's been changes to your image. So it's just one to watch out for, unless you want to work it in this way, in which case it's fine. So you also need to get information about your running containers. So if you want to, I don't know, send traffic to your containers, you can get more detailed information about them. So in the previous slide, this one, we said we were going to bind ports here. So if we were on a minion that had this running and we did curl localhost 5,000, we would get the running container. But here, maybe we don't want to actually bind just one container to that port, because if you bind that one container to that port, then that port's used. And you can't create more containers that will run on that port. So perhaps you want to send traffic to the private IP address of that container. So you can use docker.getContainers, which would get you, as if you were doing a Docker PS, basically. That would give you the most basic information about your containers. It wouldn't give you like private IP addresses or anything like that. You can do docker.getContainers inspect equals true. And what that will do is for all your running containers, it will then do a Docker inspect, and that will give you much more granular information about your running containers. So that will give you everything. So that would say the environment variables are exposed to it, the ports that are exposed to it, the IP address it's running on, all of that information. Or if you just want to run it against one particular container, you can do docker inspect foo, and that will give you that more granular information. So this is just an example. You can see here, we can see that the IP address that the container is running on. So we could say curl 10.1.0.13, colon 5000, and we would get whatever's running. Okay, so for Nginx, we've got our container running, but we don't want to bind ports to it. So in this instance, we're basically going to create an Nginx configuration that will hopefully bind to send traffic to our running container on that 5000 port. Fairly standard salt stuff there. But this is what will be in that Nginx config. So if we want to run a container without that port binding stuff and say we're going to want to run loads of containers, this is how we could do it, for example, although this would just be for one. We would do salt, docker.inspect, container foo, and then we get that IP address through network settings IP address, and then we can just pop it into the proxy path part of Nginx. And then Nginx would reload, and then if we did curl localhost, we would get what's running on that container. I will do a demo of this later So you'll be able to see it running, hopefully. Another important thing you need to make sure you do is always clean up after yourself. So every time you do a Docker pull and you're pulling down that latest image, you'll end up with old images that are hanging around doing nothing. And Docker calls them dangling images. They end up untagged and they're just hanging around doing nothing. So it's important that you remove them, otherwise they're just taking up space on your hard disk. Again, we use command.wait and we can watch for when we're removing containers. And it's important you do it after you've removed your containers, because if you try and run this before you've removed your containers, then the command will fail, because it could potentially try and remove an image that's still using that old image, and then it will just fail. Okay. So as I said, we can run multiple containers. So this is the great thing about Docker, is that we've got that soon foo image, but say we want to run like 50 containers of that, and we can do that really easily. So we can just create a for loop in our salt states and just loop over the original salt states we had earlier. So we can say for foo 1.absent, we check to make sure that any changes to the soon images means that we remove this image. I've actually added something new in the demo in here, because you need to make sure that you put an unless here, otherwise, or only if in here. Otherwise, unless you check whether the image already is running or not, again, it will fail. So you're in a chicken and egg situation. You haven't created the image yet, but you're already trying to remove it, and then it would fail. Once we've cleaned up after ourselves, we can create a new container, and then we can run those new containers. And then you would have 4 running new containers. So then we can update our Nginx config to include that. And the only extra thing I'm putting in that is I'm just telling the Nginx config that we're going to run 4 containers. And inside that, we create a new upstream backend block. So this is a way of defining multiple backends that we want to proxy to in Nginx. So we're just going to loop over that number. So it's 4 plus 1 because it's 4. So we say we want to inspect foo-1, for example, if we were doing this loop the first time. Make sure we make it a string. And then we get the information of that one container, and then we put that into the upstream backend. We'll just change the proxy pass to proxy to the upstream backend, and then it will just, Nginx would normally load balance across those multiple backends. So there you have multiple containers running on the same image, and Nginx proxying to those servers. So I mentioned logs in the first half. Logs in Docker are something that is currently being worked on. So for example, if your app is like logging everything, so you're logging all your requests, you're logging errors and all that stuff, all of that stuff just gets shoved into a logging file. But they don't live in like var log Docker container. They live somewhere else, and they don't get rotated. You can hack around it. You can create a logging config so that you can rotate them, but you have to stop the container. Because the container will be using it, obviously, so you can't then rotate them. It's something they're working on at the moment. It's probably best anyway to set up your app to log to a central logging store like Logstash. You get much better view over your logs that way than having to go onto a server and viewing the logs normally. So for Do It, obviously this isn't an open source project, so we want it to be private. So Docker Hub allows you to create private repositories. So in your Salt pillars, the only thing you need to do to get that running is you just say Docker registries. This is obviously Docker Hub, and you give it your credentials. And that's all you need. Docker Salt will handle the rest from there. So if you try and pull a private repository and this pillar exists, it will just download it. Same for pushing and building. So, shall I do the demo now or after this? This is going to be about continuous integration and stuff. It's up to you guys. I'll do it now. All right. A live demo. Okay, So I went over 3 basically versions of salt states that we could have for running our Docker stuff. The first example was just running it normally on port 5000, and there was an Nginx version, and then running a multiple container version. So I'll go through the first one first, and then we'll run some high states, and then we'll see what happens. Hopefully it will work. So this is the first version. This is the salt state file in its entirety. You'll see that up here, I've added that only if statement in there. So it just does a Docker inspect to make sure that foo exists. If that doesn't exist, that will return false, and then that command.wait won't run. So everything can run normally. So let's try and make this work. By the way, I am running all of this inside a Docker container that's got a salt master installed, and I can show you that Docker file a bit later so you can see how it works. Okay, so this is all the stuff I did earlier to make sure that my demo would work. Okay, you probably can't see that. So let's run foo1. So over in this tab over here, I've got that app over here. So this is the original Flask app. I've got a few things here that we can change, rebuild the app, push it up to Docker Hub. So we've got some changes, and you can see that those changes reflect when we run the states. Okay, so I've got a foo state file. That state file will include all the dependencies, like has to have Docker installed, has to have the Docker service running, has to have Docker Pi. So that's all that basically exists in the state file, and we'll download the image and run the container. So I'm just going to make sure that I clean myself out so you can just see that it works. Okay. So you'll see that I have absolutely no containers at all. I probably will have an image though here. Oops. So I've got one image down here, which is soonfoo, so it already exists, so it won't need to download it again. So if I call the foo high state, this should be pretty quick because it shouldn't need to download anything, I hope. So, yep, so nothing changed. So here we make sure that the container is installed, and we make sure that the Docker foo is running. So if I do Docker ps now, see we've got our new container running, and you can actually see, if I can get it a bit better, so you can see hopefully that we've got up here ports 5000 on the container exposed to 000 on the host and on port 5000. So hopefully if I go into Chrome, by the way, I'm running boot to Docker, so this is my boot to Docker IP. 5000, should I say? Hello world. So there it is. And just to prove that that's coming from our Docker instance, we do docker logs foo, and you can see that that's the request that just came in. So that's that. So the next point was to get Nginx working. So I'll pop on over here. So foo2, close that. So up the top we've got an include, dependencies again, just make sure Docker's there and running. Installing Nginx, make sure Nginx is there and running. So we're going to pull the latest image again. We're going to make sure whether it's absent or not, whether we need to update it or not. So I'm going to push a change to that image. I should probably do that now. So we do it. Actually, we'll do this one. So we build our new image. This is installing the application. Okay, and then we can push it. A lot of that came from the Docker cache. I haven't talked about the Docker cache really. A lot of that stuff was already pre-fetched, and there are already layers already existing So it didn't need to like rerun apt-get, update, and install all the dependencies. They were just in my cache and ready to go up. And you can see here, like all of the layers were already pushed. So it doesn't need to push everything. The only thing it's going to push is the new changes to the app. So while that's running, again, so because the image has changed, this will run because we've got some changes to the image. And it will also run because we have a foo container already running. After that, we will then obviously create the Docker container, and then we'll pop down to the running. The running is much simpler than what we had in the other example because we're not doing any port bindings here. So Nginx is going to do that thing where it would inspect the running container, get its IP address. So here is the sort state for the Nginx config. And then we've got cleanup down here to remove the old image. So you should be able to actually see Nginx foo2. So you can see here, setting foo, getting the information about it, and proxying to that server. So hopefully, right, so that's pushed. So instead of running foo, we'll run foo2. This one will take a little bit longer because it will have to download a new image. Hopefully not that long, so I don't stand here saying nothing for a little while. These images should only be like a few 100 meg, if that. It will depend on your app and what other stuff's installed on it. Normally they don't take that long to download. And hopefully, I'm praying that our 20 meg connection is working pretty well right now. But at least, so there you go. I saw that it had some changes, and then you can see the changes to the Nginx config, and then you can see it deleted the old containers, or the old images rather. So there we go, there are the changes to the Nginx config. So it got that IP address from inspecting the container. So hopefully, if I now do this again, oops, it's definitely running. This will be the curse of live demos, because everything then goes yellow and it doesn't work.
Sorry about the yellow.
At least it's on brand. Oh, there we go, right. So that should have worked. Let's try and get the IP address. So there's its running IP address. So it did work, you can see it there. Hello, Salt, London, via Nginx. I don't know why that didn't work through my browser, but you can see that it worked. It's probably just a routing thing from my browser.
Are you finding Nginx on WordPress?
That's a good point. There you go. Right, there we go. So we can see that the changes that I made got pushed up to Docker Hub, it pulled it down, and now it's running. Great, thanks. Okay, and then the next bit will be running multiple containers. So for that one, so here, what the app will show you, it will tell you which container we're in by host name. So all the containers' host names will be the random container hash, like a GitHub hash, a git commit hash, for example. So again, we build. And push. And back over to Salt. Over to foo3. So again, foo3 is the same, except up the top, what I'm saying is I'm saying that I'm going to run 4 containers, and then we're going to loop over that. I put a +1 in the end because we're starting at 1, so we don't want foo0, we're going to have foo1, 2, 3, 4. And we just rename our states. So instead of foo-absent, it's going to check for foo1 is absent, depending on whether there are any changes to the images, whether foo1 already exists, etc., and then we'll remove it. And again, so when we're changing a few things, so instead of the cleanup command waiting down the bottom, we put the wait in up here, just to make sure that it triggers in the right places. Otherwise, I have to put for loops everywhere, and that just wouldn't be very neat and tidy. Other than that, it's all the same, except for just renaming it for the number of X's we've got. Again, for the Nginx, we pass in a context saying we're running however many containers that we said we want to run. You could decide that based on grains from how many processors you're running, how much resources you've got available. This could all be really dynamic and very elastic and scalable to what your server is doing. And then cleanup is the same. So hopefully that has pushed. So now we'll run foo3. Again, it will fetch a new image. That didn't take very long. So yeah, you can tell when it hangs a little bit at this point that, okay, it's found some changes, and it's downloading them. After this bit, I'll talk about some bonus stuff that we've been doing that has, for us, become like the holy grail of deployment. Most of us come from backgrounds where we've had to physically sit at a computer and type a deployment command to get stuff up on servers, and it's often not worked, or we've copied scripts around from different projects and all that kind of stuff. It's not very easily maintainable. That failed. Maybe because... That should have worked. It worked earlier. I'll try it again and we'll see. But probably not. It looks like it's just failing on the check. I could just remove that bit, just make sure that you can see that it actually does what it should. Oh, there we go. I don't know why that failed the first time. Okay, so you can see that the change to the Nginx config is it's gone and inspected those new running containers. We've got 4 of them, so we've now got these server blocks in a new upstream block in the Nginx config. Changed the container, we've started foo4 there, we should see other ones like started foo1 here, etc. foo3. So hopefully, if I rerun that, you'll now see that I'm in different containers every time. It's that easy, basically. So that concludes the live demo.
I'm going to live a little round.
Okay, so we use CircleCI as our way of testing our applications. CircleCI is great. It's also Docker-based as well, which is great. So a lot of the stuff, when you run your test suites, a lot of stuff is already cached. So there's no a lot of hanging around for install times and stuff. A lot of stuff already exists, which is perfect. This is an example of a CircleCI config. I don't know how well this will work in Travis or Jenkins, for example, but I'm sure there are solutions. So in this CircleCI config, we're just telling Circle to use Docker. Here we're creating the environment variables repo and tag. And if we're on the master branch, then we just replace master branch for latest for the tag, because on Docker, your latest master branch is called latest. And also we replace slashes with dashes. So for example, if you're pushing a branch and it's called feature foo, for example, that's not a valid tag name for Docker, it has to replace it with a dash. So if you're running a private repository, for example, like we do, you're going to want to have a Docker CFG config which contains your Docker email auth and all that kind of stuff, so you can pull your images down from Docker. And then what we do is we override Circle's normal default dependencies for running our project, and we build our Docker container in Circle. The only downside of this is that your builds run in isolation. So you can't leverage the Docker cache, which I was able to show you in the demos, because I was able to build the images so quickly because I already had those layers cached. They already existed. In Circle, they don't. Or even if you have automated builds on Docker Hub, they don't exist because everything runs in isolation. So it's just something to bear in mind, is that your builds will take a little bit longer. So to test, what we do is we run our tests inside our Docker container. That way we know that our code works in the environment that we're going to be deploying. That's very key. Before, for example, if you had your test suite and you ran it locally and then you pushed it up to your deployment server and then it didn't work, then you've got environmental differences. And this way we know that our environments are always the same. And then we have a deployment section. This is another thing about Circle, which is good. So if we're on the master branch, it will do a Docker push with whatever repo our name is and tag is straight up to Docker Hub for us. So the next part of getting the Nirvana is getting Salt to trigger high states based on changes. Where if your build was a success, you probably want to be pretty confident that it's safe to go up, providing you've had good code practices, like you've code reviewed and done pull requests and stuff. So I'm sure you're all familiar with the REST API, so we put this in our Salt master config. In this example, I've disabled the webhook auth. Probably don't want to do that in production. You should always protect your Salt REST API, especially if it's open to the public from like services like Circle, over SSL, maybe put it behind auth basic, have proper roles set up in your Salt master config, etc. And then we're using the reactor to listen to that event. So in the event that the Circle pushes to our REST API endpoint, Circle success, we will run this state file. And then we just want to make sure that we run the Salt API service. And then this is the basic state. Ours is a little bit more complicated, but I just took the highlights. This is using the PyRenderer. So this is what's in our deploy SLS. And what will come in when this is what will get executed when Circle posts that webhook. So basically we're saying, okay, we've had a successful build. Let's call a high state on all our servers. Let's just deploy. Of course, customize it to how you need it. So, for example, this is what Circle might send. So wherever your REST API sits, hook, Circle CI, success, this will get run. Slack notifications. It's a big thing for us. We work in Slack a lot, so we like to get stuff like this. It's nice to see that if you're not actually explicitly running commands on your Salt master and you're deploying stuff, it's key, I think, that you know what your Salt master is doing as much as possible. So you don't know that, so you know that you deployed stuff, right? That's important. So this is a simple, well, kind of simple. It's just a Python script that would post a payload to our webhook in Slack, and it looks something like this. And then you just add this into your reactor event. And then you just add, so like I say, you just add that into the end of your Circle deployment, or Jenkins, or Travis, or whatever you're running, and that's it. So once your code is committed into GitHub, your build runs. Once your build is successful, it gets pushed to, it tells Salt, hey, we've got a successful build, it's up on the servers, you can deploy it. It's deployed. Questions?
Well done, mate. Good effort.
Any questions? Yep.
How do you do orchestrate? Do you mention linking containers in Salt?
So linking containers, linking containers on one server is okay. We want to run a very elastic service, so our API servers need to scale across multiple servers. Linking containers over multiple servers is quite hard. There are solutions for it. CoreOS apparently can do it. I'll just get off the yellow. CoreOS can do it using the Docker ambassador pattern. I've tried it out. It hasn't really fit us. The way we're linking stuff is through environment variables. So we're doing that through configuration and pillars and grains and that kind of stuff. So we know where our stuff is running and we can link to stuff through IP addresses and stuff like that. And that way our stuff can be quite elastic and grow as we need it to.
If you're doing it through environment variables, what happens if one container dies and has to restart it? Do you then shut the entire thing down and bring it up again to re-enable the correct IP?
So we don't have anything at the moment for that. A lot of our stuff, so RabbitMQ, for example, runs in a Docker container. So if that went down, the worst that would happen is that we would be notified about that because we've got monitoring about it. The worst that would happen is that our email alerts don't get sent out. If our app servers containers go down, they're not dependent on anything, like there's nothing listing in our app servers. So again, we'd be notified if they're down and we can look into why they're down. But we have 3 different environments that we deploy to. So our develop branch on GitHub deploys to our dev servers. Our dev servers run our most up-to-date code. So if something's failing on dev, we'll know about it because it's where we're deving stuff. Once we start creating releases, things go up to QA servers. And once they're on QA servers, this is where our client checks stuff. This is where we check stuff, like to make sure that the new features are running. Again, we'll notice there if stuff isn't working right. And then once the release is done, that's it, it goes up onto master. And we should be fairly confident at that stage that things won't break. Hopefully. It does, it has happened. Like inconsistencies in our database has been one of the main things, like migrations that ran on QA fine, didn't run on master fine, which has meant that our apps have not come up properly. But like I said, we've been notified. It's something that we probably need to be better at. But
the whole system needs to be better at it in the sense of
yeah, Docker's just not a tool for that, and you need to be relying on other things. Yeah, it's hard.
So I've got a question. Given that it's the whole thing that you've worked on, it's under the assumption that it's just one application.
Yes, so we are running one application. Well, actually we run a couple. So we run for Do It, we run an API backend service, and we run a front end service. So the two are very separate, they communicate over an API. We also run some services like Logstash and RabbitMQ and stuff, but they're all containerized as well.
Yeah, but they're distinct applications. What if you want to run a platform customized for different sort of like profiles or something? Mm-hmm. Is there a way to actually create the whole logic in the SaltStack?
Yeah, of course. Yes.
And then pass it as an argument, the name of the the profile or something like that?
Yeah, it could all be done from pillars and grains and environment variable. So you could set a grain on your server that says client equals client 1, for example, and your salt states could operate on that.
So each container will be for each client, sort of?
No, not necessarily. It depends how you're viewing it. So Do It is a project that will be a platform. So Do It as a platform will support multiple services. So we've got the Do It service, but we'll also be supporting another service for Team London, which is another volunteering service. For us, the way we've designed our application is that the APIs, like the front-end clients, can hit the same API containers, but through their request headers, they're sending the container. The way the application behaves determines which database they use and which assets they serve, and that kind of stuff. So it's not really a salt thing that we've done for that stuff. It's more at the application level for us. But you could do it in Salt as well. You could have, based on grains or other configuration variables, you could have service specific for one client and service specific for another client, depending on how you want to set it up. It's all very flexible and up to you.
I was just struggling to actually run one salt state, a really complicated one on orchestration, just giving it a command line argument to say, run it for this client, and just couldn't find any way to do that, other than replicate the states or something.
I mean, for us, like, I'm not on our master server right now, but if I wanted to like deploy to a specific, we call them roles. We have several servers that have different roles applied to them. So some servers are API servers and some are Celery. We target them like Salt. For example, that would target our QA servers because they've got the environment QA assigned to them, and then we could say and g-apt role API, for example, and that would target, so only for our QA servers would it run the salt state for API stuff. So that's how we do that. Anything else? Nope. Speak now.
Are you happy running Docker in production?
Yeah, we're really happy with running Docker in production. We also use it for development as well. So all of our, we don't use Vagrant or anything like that. So it's really
Do you
easy.
use Fig Up or something like that?
Yes, some of us use Fig. I think Fig is great for like getting the whole stack up and running in one go. Our front end team use that more than the back end team. I personally use Fugu, which is, so Fig's more of an orchestration tool. Fugu is more of a wrapper around the Docker command line interface. So I can show you my Fugu config. So good, you can't see passwords in here. So I just have a Fugu config. So like I could do Fugu run development, for example, and that would start a development web container based on. So it's just normal YAML config basically, and Fugu consumes this and then will execute the appropriate Docker commands to get that system up and running. So I prefer this.
You get that from Salt anyways. If you
Yeah, but for local development, you're not going to be running in Salt, so you need a way of upping your infrastructure in a way you can develop against it. So I like Fugu, it's great, you should look at it, but Fig is also a good one to use. Cool.
There we go.